Hi everybody, I am Mrs. Leong and I will be teaching 7.5 Properties of Logarithms. All right, so today's lesson we are basically going over 3 properties of logarithms as you see right here. And then we'll be kind of experimenting and playing around with these properties. Okay, so the first one is the product property of logarithms, the product property of logarithms. So basically what that's saying is that if you have a log, and in the argument, right, inside the log right here, you have two things being multiplied. What you can do is you can actually split that up into two logs being added. All right, so for example, log base 2 of 5 times 6, you can split up to be log base 2 of 5 plus log base 2 of 6. All right, so when it's a product, you're going to add when you separate them into two logs. Okay, so product turns into addition. All right, let me show you another example up here in our warm-up. So number 1, all right, you would have log base 2 of 4 plus log base 2 of 8. All right, and remember, log always asks what exponent, all right? So log base 2 of 4 is asking 2 to what exponent gets you 4. So that answer would be 2. And then log base 2 of 8 asks what exponent. So 2 to what exponent gets you 8, and that would be 3. So this simplifies down to 5. All right, so that is the product property of logarithms. Okay, let's try the quotient property. Okay, so the quotient property, this is saying that when you have a single log and you have two things being divided, you can split that up and subtract the logs. All right, you subtract the logs. So the example here, we have log base 2 of 5 over 6. This you can make or re-express as log base 2 of 5. Start with the numerator, and you subtract log base 2 of the denominator. All right, so division, when you split it up, you use subtraction. Okay, so for example, number 2 up here, we have a log base 2 of 4 over 8. So this is equal to log base 2 of the numerator 4 minus log base 2 of the denominator 8. Okay, so we ask what exponent? So 2 to what exponent gets you 4? That's 2. And then log base 2 of 8, so 2 to the third power is what gets you 8. All right, so this is equal to -1. All right, and our last property is the power property of logarithms. Okay, and basically what that is saying is if your argument inside the log has an exponent, you can actually bring down that exponent. All right, you can bring down that exponent. Okay, let me take the box out so you can see that better. So you can bring down the exponent, and then you have p multiplied with the log base b of m. All right, so let me give you guys an example. Let me go back and box this again. All right, so for example, if I have log base 2 of 6 to the 5th power, all right, I can bring down that exponent 5 and multiply it in the front. So this becomes 5 times log base 2 of 6. All right, so that's 5 times log base 2 of 6. Okay, let me show you one more up here. So number 3, if I want to simplify that, I see I have an exponent of 3, which I'm going to bring down. And I have 3 times log base 2 of 4. All right, now log base 2 of 4, I can simplify just that part, and that is 2. So that's going to be 3 times, that's 2, which gets me 6. All right, and that is my final answer. Okay, so those are the properties. Let's kind of do a few examples just to get you guys a little more used to it. I'm going to go a little bit out of order. So I'm actually going to jump to number 7 through 12 to start us off with practicing these properties. All right, so starting with number 7, we are asked to solve each equation and then check our solutions. Okay. So when I see check the solutions, typically it means, okay, there's some restrictions about log. So just remember, when we have a log, the argument has to be greater than 0. So I think that's what checking the solutions means. I have to make sure that we meet that criteria. All right, so starting with number 7, what I notice is I have 2 logs on the left-hand side with the same base, and they're being added. So if I go back to my properties here, if I have 2 logs being added, I can actually go this way, right, and make it into one single log, right? And what I notice is if it's being added, I need to multiply, all right, to combine it into one log. So let's do that. Let's combine these 2 logs to make it one single log by multiplying the arguments. Okay? And that's equal to log base 3 of 42. Now, the reason why I wanted to make it into one log is now I can just set the arguments equal to each other. So I can ignore those, and 7x is equal to 42 is what I'm left with, giving me x is equal to 6. Now I'm going to double check and make sure that if I were to plug that back in, right, all the arguments would still be greater than 0. This is the only place to plug in x, so it satisfies, that is greater than 0. Box it, final answer. All right, let me go ahead and show another one. Let me jump to number 10, since that's a little more similar. All right, so number 10, same thing. I have 2 logs. I have one here, I have one here. And I want to combine that to be one single log. So I'm going to multiply the arguments. So log base 7, and this is going to be x times x minus 1 on the inside of that log. All right, so let's go ahead and simplify that. So this is going to be log base 7 of x squared minus x is equal to log base 7 of 2. Oops, too big of an eraser. All right, now that we have 2 logs with the same base being equal to each other, I can just set the arguments equal. So this is just x squared minus x is equal to 2. Since I have a quadratic, I'm going to subtract the 2, get everything on the left-hand side, and set that equal to 0. Go ahead and factor that with whatever method your teacher has taught you. There's so many out there. But I've taught my students to think what times what equals x squared. So x times x. What times x, what gets you negative 2. So that's negative 2 and 1. And just cross multiply. I get 1x. Cross multiply, I get minus 2x. And that gets me negative 1x, which is that middle term. So once you have that middle term, you know that your factoring is correct. All right, so that factors out to be, first parenthesis will be x minus 2, second parenthesis will be x plus 1. All right, so then that factors out to be x minus 2 times x plus 1 is equal to 0. All right, let's move up here and I get x is equal to 2 or negative 1. Now remember, we got to check and make sure we didn't make any arguments equal to less, or excuse me, anything in the argument has to be greater than 0. So let's see if we need to throw out any answers. And it does look like, ooh, negative 1. Yeah, when I plug in negative 1 here, that log does not look happy. All right, has to be greater than 0, so negative 1, we got to toss. When I plug in 2, that log is okay. When I plug in 2 into the other log, still okay, still greater than 0. So my final answer is just going to be x is equal to 2. All right, and that is number 10. Okay, let's try a few more. Let's go back to number 8. All right, so number 8. I already have just one log, but I noticed the 2 out in front. So what I'm going to use is I'm going to use the third property. All right, so the third property, if I have a number out in front, I can bring it up as an exponent, like going the opposite way. All right, so I'm going to do that with number 8. I'm going to bring up the 2 as an exponent of x. This is log base 4 of x squared now is equal to log base 4 of 25. All right, now I just have log base 4 of an argument, log base 4 of an argument. I can just set the arguments equal and ignore the log. Square root both sides. Now be careful. Here I get plus or minus 5. But the negative 5 doesn't quite work because when I plug in negative 5 back in, my log has a negative argument, which is not okay. So I'm going to take out the negative. Don't want that one. So just the positive 5 will be your final answer. Okay, continuing number 9. So number 9, I have, subtraction happening. All right, so this is going back up to our second property. When we subtract, if we're going to combine it, we're going to divide the two arguments. All right, so let's go ahead and combine that into one log and make that a division. So log base 5 of 72 over x will be the left-hand side. Right-hand side, I have log base 5 of 12. I can set the arguments equal to each other, and I get 72 over x is equal to 12. Multiply x on both sides, and I get 72 is equal to 12x. Divide by 12, and I get x is equal to 6. Double check it doesn't make any arguments negative, and it looks like we're okay. All right, so x is equal to 6 is my final answer. Okay, going to number 11. Let me erase some of this. All right, so number 11. And feel free to pause the video at any time. If you want to try the problem on your own, you can pause the video, try it, and then just check your answer and see if we get the same answer. Okay? So at this point, I think number 11 and 12, you might be able to just try on your own. So feel free to pause it and just fast forward to where the answers come up and see if we match. All right, but just in case you need an explanation, I'll go and explain it. So number 11, what I do is I want to combine the left-hand side to be one log. I see addition, so I'm going to multiply the arguments. So 5 times x, and that is equal to 3. All right, so I got a little surprised there because I was like, wait, where's the log? I usually have a log there, but that's okay, because what we can do is we can rewrite this into exponential form. So let's bring up that base to be the base of an exponent of 3. So this would be 5x is equal to 3 to the third. All right, and just in case you're like, which 3 is which, this 3 is the base, this 3 became the exponent. Okay. All right, so simplify that. And then we have 5x is equal to 27, and x is equal to 27 over 5. Double checking the argument, everything's still greater than 0. So final answer, there it is. All right, and lastly, number 12. We have a few things happening. Okay, so first I can bring up the 2, and this will be log base 2 of x squared plus log base 2 of 9. And because it's plus, I can multiply the argument. So this is log base 2 of 9 times x squared is equal to 2. All right, let's go ahead and bring up that to put it in exponential form. So that's 9x squared is equal to 2 squared. So that equals to 4, which gets me 4 over 9, running out of room. Square root both sides, and I get x is equal to plus or minus 2 over 3. And my guess is we have to toss the -1. Yep, because x up here can't be negative, I am going to just take x is equal to 2/3 as my final answer. All right, and that is how it's done. Okay, those of you guys who tried it, hopefully you were able to get those. I think number 12 was probably the toughest one, so if you got that one, good job. That had a few properties mixed in there, so good job on combining those. All right, let's go back. Let's go back to number 1. All right, 1 through 6 here. So what's happening is they give us some of these values, all right? They give us that log base 4 of 2 is equal to 0.5. They give us that log base 4 of 3 is this decimal. And they give us that log base 4 of 5 is this decimal. And we want to use those values to approximate these 6 that they give us, assuming we don't have a calculator. Okay, so let's see what we can do. So for example, let's do number 1. Log base 4 of 128. Okay, so in order to find out what that is, I'm going to be using either 2, 3, or 5 to get 128. All right. I feel like it's going to be the 2, right? Because it's even. So let's see how we can use 2 to get to 128. And so if I use 2 and multiply it with itself again and again and again, I would find that 2 to the 7th power is actually 128, right? I would just keep multiplying until I got 128. So it turns out that 2 to the 7th is equal to 128. So I'm going to replace 128 with 2 to the 7th. All right. Now with our third property, I can bring that 7 down to be 7 times log base 4 of 2. And from what they give us, log base 4 of 2 is 0.5 right here. So if I multiply that, I get 3.5 as my final answer. All right. So your job is basically to re-express the original problem into a log base 4 of 2, 3, or 5. Use the properties and then simplify. Okay, let's try another one. Number 2, because these can be tricky. It's almost like trying to solve a puzzle. All right, so we have log base 4 of 48. Okay, so to get 48, if I do, 2 times 2 times 2, I get 8. If I times another 2, I get 16. If I times another 2, I get 32. If I times another 2, I get 64. So I can't just do 2 to an exponent to get 48. I need something else. All right. So what I noticed though is if I do 16 times 3, I get 48. All right. So let's go ahead and do that. Let's do log base 4 of 16 times 3. And that's 48. All right, and then 16 is 2 to the 4th power. Okay? Now let's use our properties and let's split these guys up. So we got log base 4 of 2 to the 4th plus log base 4 of 3. All right, using that first property. And then I can bring down the 4 using the third property. And that gets me this. Okay, so let's just go ahead and substitute in the values we know now. So log base 4 of 2 is 0.5. And log base 4 of 3 is 0.7925. All right, so this is 2. And just add them up. So 2.7925 is our final answer. Okay, let me go ahead and do number 3. All right, so number 3, I'm trying to get 24. All right, so I need to get 24 using the numbers 2, 3, and 5. I don't think 5 is going to help. Oh, well, 8 times 3 gets me 24. And 8 is to the 3rd. All right, so we can split that up by adding and then bring down the 3. All right, so this is very similar to number 2. All right, substitute, and this gets me 1.5. Add that up, and we get 2.2925. Okay. All right, let me do a few more, and then I think you guys should be good. All right, so number 4. All right, so number 4, I have log base 4 of 3 over 4. All right, so we can automatically split that up to be log base 4 of 3 minus log base 4 of 4. Okay, so that's using the second log property. And log base 4 of 3, they give us is 0.7925. And log base 4 of 4 is actually just 1, right? 4 to the 1st power is what gets us 4. So we can just simplify that to be 1. And we get negative 0.2075 when we subtract. All right, so you don't necessarily have to use the stuff that they give us up in the problem. You can use just simplifying. Okay. All right, I would say you can try 5 and 6 on your own. So I'll show it still, but if you want to pause the video, feel free to pause it, try it, and then check your answer once you're ready. All right, so number 5, this would be log base 4 of 5 minus log base 4 of 2 Log base 4 of 5 is 1.1610, which they give us up here. And log base 4 of 2, they give us is 0.5. So subtract, and I get 0.6610. All right, and then number 6, we have log base 4 of 2 minus log base 4 of 5. This is 0.5. This is 1.1610. Subtract, and we get negative 0.6610. All right, and that is the final answer. Okay, in case you need to see any of the previous ones, there you go. All right, and let's wrap this up, guys, with some word problems. So number 13, it says the pH of a substance is defined as the concentration of hydrogen ions in moles. It is given by the formula, that one. Find the amount of hydrogen in the fog in LA, yikes, which has been measured to have an average pH level of 2. Okay, so basically let's plug in 2 for the pH and see, what we got. All right, so I got 2 is equal to log base 10 of 1 over H plus. And don't let that plus kind of freak you out. It's just a variable. All right, so H plus. And we're looking for H plus. Okay, so let's get this into exponential form. If you want to move the 2 to the other side, feel free, because sometimes people see it better like that, and then you can bring that 10 up, and we get 1 over H plus is equal to 10 squared. And that's equal to 100. All right. So I'm going to go ahead, and there's different ways you can do it. I just think of it as flipping both sides. So that means H plus is equal to 1 over 100. All right, and that is in moles. You can also just multiply H plus to both sides and then divide 100 on both sides, whichever you're comfortable with. All right. And lastly, number 14, the loudness L of a sound measured in decibels is given by that formula, where R is the sound's relative intensity. Suppose one person talks with the relative intensity of 10 to the 6th power, or 60 decibels. All right, how much louder would 100 people be talking at the same intensity? All right, so I think what's kind of confusing here is that they're giving us 2 values. So I'm going to go ahead and let's see if we can figure that out. If I were to plug in R is 10 to the 6. Okay, I'm going to plug that in. This is for one person. What I get is I can bring that 6 down. So I'm going to simplify what's inside the parenthesis here. I can bring the 6 down. And then this is going to be log times 6. And then log base 10 of 10 is just 1. So that's where the 60 decibels is coming from. All right, so I do want to plug in R though as 10 to the 6th. Okay, so now let's figure out how loud 100 people would be. So I'm going to do 100 times 10 to the 6th. Now see what the L is there. So this is going to be 10 times log base 10 of 100 people times 10 to the 6th. All right, so then this is going to be 10 log base 10. 100 is 10 to the 2nd power. And then if I simplify inside the parentheses, man, there's a lot of 10s here. Add the exponents and we get 10 to the 8th. All right, So I can bring down the 8. So this is 8 log base 10 of 10, which is 1. So 8 times 1 just gets me 8. So that gets me 80 decibels. All right, now they do something really sneaky here. It actually says how much louder, right? How much louder. So if you're going from 60 decibels to 80 decibels, that is 20 decibels louder. All right, so sneaky, sneaky. Always check the question before you box your answer. All right, guys, good job. That is lesson 7.5.